Grade 12 learners, welcome to today's geography lesson. My name is Rina van Heerden. My co-presenter is Cynthia Zondi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Centre. This afternoon, we are going to focus on preparation for paper 1 for the final exam. And as you know by now, paper 1 consists of climate and weather and geomorphology. I'm going to go through question 1 with you, which is all about climate and weather. Remember, we're not covering all the topics in climate today, but we are looking at a few topics that might be a challenge for some of you. We want you to understand and answer questions on climate and weather and geomorphology as it's going to appear in paper 1. Let's start. Various options are provided as possible answers to the following questions. So, we're giving you options. The examiners are giving you options for a specific question. You have to choose the answer and only write the letter A to D next to the question number. So you have question 1.1.1 up to 1.1.8. But we don't want word answers. You only have to choose between A, B, C, and D, and the question clearly instruct you to only write down A to D. So please, boys and girls, we saw in the past prelim paper that some of you wrote words down. Okay, so I have the following question. Mid-latitude cyclones occur throughout the year, but it affects South Africa mostly in summer, winter, spring, or autumn. Remember, you have to choose a letter, not a word. So now I am very much sure that you know your mid-latitude cyclones, and the keyword or the catch in here is that it occurs throughout the year, but that's not what your teacher told you. But here is the catch. It affects South Africa in which season? I'm going to give you a while I go to the next one. Think of that one and plot down your answer so long. The various stages of development of a mid-latitude cyclone are referred to as. Here is the keyword or the words that you need to highlight. Stages. Now you must think of the 4 stages. But if I have that 4 stages, what do we call it? So let's look at the options available. Frictional drag, veering, cyclogenesis, or backing. Now, boys and girls, answer for 111 is winter. Why? Because in your notes, we said that several times, mid-latitude cyclones affect South Africa in winter. It is in winter that the cold front moves over the country. 112, the various stages of development of a mid-latitude cyclone are referred to as cyclogenesis or C. So my answer here will be B, and here it would be C. And for each one of them, you will get 1 mark. Now, what I want to show you here is with question 1. Question 1 is a low order question. That means it's an easy question. Easy for you to score 1 mark. Why? You must be able to answer this question. One of the topics in the exam guidelines is asking you you need to know which time of the year does it occur. Now remember, the catcher is that a mid-latitude cyclones develop right through the year, but it only affects South Africa's weather in winter. We'll see later why. So for 1.1.1, all of you must have the correct answer of B. If I go to 112, cyclogenesis, this might be a little bit of a question where you need to think, but for here, you need to know your concepts. And during these lessons, several times, we focus and we emphasize the importance of studying concepts. Now, the definition for cyclogenesis is the development of a cyclone. So if something develops, it obviously goes through certain stages. So stages of development is another word for it, is cyclogenesis. Make sure you know your concepts. The wind belt that drives the mid-latitude cyclone is referred to as A. Northeast trades, B. Southwest trades, or C. Easterlies, or D. Easterlies. Remember, you have to choose the correct word, the correct letter. Cumulonimbus clouds are associated with the A. Cold sector, B. Warm sector, C. Cold front, or D. Warm front of the mid-latitude cyclone. So I want to know where in the mid-latitude cyclone do I find my cumulonimbus clouds. So 113, I'm going to go over it with you again. So quickly think and write down the answer. The wind belt. So wind belt is what you need to know of the mid-latitude cyclone. It is that specific wind belt. And what's going to help you here is the direction of flow. Direction of flow of a mid-latitude cyclone. Is it the northeast trades, A, B, southwest trades, C, easterlies, or D, westerlies? Quickly write down your answer. Then we go to 114. Cumulonimbus clouds are associated with the cold sector, warm sector B, C, cold front, or D, warm front. So you have your answers for both of these questions. So let's look at the answers. A, 113 belongs to D, westerly. So my answer here would only be the letter D. 114, well, let's see why. If I have that specific map, you know this map, there is the area. Those black lines are the areas where mid-latitude cyclones occur. So if you look at these arrows, all of these arrows facing east, but that means it moves from west to east. So a wind gets its name from the direction it comes from. So all of these air movement is from the west. So that is why it is called westerlies. So yeah, boys and girls, this is a very important diagram. You might not get the diagram, but you might need the diagram to answer the question. The cold front, 114, belongs to C, a cold front. Why? Here's my diagram. Remember, this is a cross section. We saw that now in the prelim. This is a cross section. If your diagram looks like this is an aerial view. This is the aerial view. This is the cross section. So there's my cold front, and The cold front here is responsible for the fact that this air rises with the steep slope of the cold front. Therefore, I will have cumulonimbus clouds that's going to form. So my cumulonimbus cloud forms here on the cold front. The mid-latitude cyclone below is in the A, occluded, B, mature, C, dissipating, or D, formative stage. Want you to clearly look at this a mid-latitude cyclone. By the way, I'm just going to emphasize again, it is the aerial view. So it is a view from above. The mid-latitude cyclone, you see there in front of you, is in A, occluded, B, mature, C, dissipating, or D, formative stage. Okay, I believe you have your answer and it's written down on your paper. So I hope most of you have B as the correct answer. Now, why B? Boys and girls, in most of the notes that you see, you will see the mature stage. I have my cold front and I have my warm front. So my two fronts are there, very well indicated. And there's my cold air. Remember, the cold air is behind the cold front. The legacy of a cold front is cold air. And there I have my warm front there. And behind my warm front, I have my warm air. Now, it's not occluded because the tail, you know that other tail that comes down here that says warm, cold, warm. If that tail is over there, then it would have been the occluded stage. The formative stage is right there at 60 degrees where I have the warm and the cold air moving next to one or parallel to next to each other. The dissipating stage is your whole, the part of the occlusion stage is after occlusion we have dissipating stage. But because of the fact that we have a clearly indicated cold front and warm front which shows you cold air, look here, here's the cold air I'm talking about, then we know it is the mature stage. I believe that all of you have this one correct. If you know your work, you will know this. A characteristic of the dissipating or degeneration stage shown below is when this is the diagram. Now, this is a characteristic of a dissipating or degeneration shown, is when the A, warm air has been uplifted, B, mid-cyclone has moved over the sea, cold air has been uplifted, or the wind is veering. Now, boys and girls, earlier in all these presentations, we showed you the technique of elimination. When you have multiple choice question, we spoke about the elimination factor. So let's use elimination here as well. A mid-cyclone has moved over the sea. He always moves over the sea. He can move over land as well. But this does not define which stage it is. This question wants to confuse you with tropical cyclones. So I'm going to take that one out. Wind is veering. I don't see any arrow in this diagram, which shows me what is veering, changing direction. But there's no arrows to show me whether it is veering or backing. So I'm going to eliminate this one as well. So we are stuck with A or C. Now the question is, warm air has been uplifted or cold air has been uplifted? There is my answer. Warm air has been uplifted. Now, why am I saying this? Because I see cold, warm, cold, warm, cold, warm, cold. Now, listen to this. Your denser cold front, remember a cold front. A cold front has got cold air. It's associated with cold air. Now, cold air is normally denser and heavier. It's heavy air because it sinks down to the ground, to the surface. Ne? Your dense cold front catches up with the warm front. And now remember, the warm front has got warm air. Warm air is lighter than cold air. So now my cold front catched up with the warm air. And because the warm air isn't dense enough to displace the cold air of it, it shifts up and slides above the cold air. So what's happening is my cold air is the heavier air. My cold air is heavy, so it's going down. It sinks to the bottom. While my warm air, remember, warm air is lighter, warm air rises. So this cold air moves in beneath the warm air and it forces the warm air to rise. It is because cold air is heavier and more dense than warm air. 117. The occlusion below can be identified as a warm front occlusion because why is this diagram that you can see here? Remember, why do we know it's occlusion? Because of this part. Ne? This part is being added. That's why this is showing me that it is a occlusion. Now the examiner is telling me that it's a warm front occlusion. Now I want to know from you, why is it a warm front occlusion? A, the cold front has caught up with the warm front. B, the coldest air is found behind the cold front. Or the warm air has been uplifted. Or D, the symbol closest to the apex. Okay. A warm front occlusion occurs when the cold air behind the occluded front is warmer than the air ahead of it. Listen carefully. A warm front occlusion occurs when the cold air behind the occluded front is warmer than the air ahead of it. So, this is my occlusion here. So this air here is cold, but it's warmer than the air that is a front. The warm occlusion acts in a similar way to a warm front. The cold air behind the front is less dense than the colder air ahead of it. So it passes over the top of the colder air. Okay, so there's my symbol of warm front, cold, warm, cold. So I have this in situation where the air behind the occlusion is cold, but it's warmer than the air that is here. So this air is going to force, this is lighter, so it will lift easily, and it will lift this air up, force it will rise above it. Sorry, it will rise above it. This is the colder air, so they are dense, so this warmer air will lift above that. Therefore, it is a number D, the symbol closest to the apex. There is the apex, and there is my warm front. Boys and girls, please make sure that you know all your information about the stages of development. Now, I just want to end off with this one. The wave stage below develops because of A, cold front that undercuts a warm front. B, warm air that moves over the cold air. C, frictional drag. Or D, wind shear. The wave stage, look here, that's the initial stage where it begins. It looks like a wave with my cold air here. my warm air. Yeah, remember there's the warm air, here's the cold air. A cold front that undercuts a warm front. B, warm air that moves over the cold air. C, frictional drag. Or D, wind shear. Your answer must be C for 118, frictional drag. As you look at this diagram, you'll see it is the wave stage. I just want to see. No, there's not another slide. Remember, if this air, it's normally at the 60 degrees latitude line. I have my warmer air that flows from west to east, and I have my colder air moving from east to west. So what's happening here, as this air move parallel to each other on the polar front, we have friction. Now, that friction that's going to cause this going to give rise to this wave stage. So it's because of the friction that's taking place on the polar front. Now, boys and girls, question 1, 2, 3, for a question like this, everybody, all of you, can have an average of 4 out of 8. Remember, there is, your teacher might have told you about the road to the 40s. We are trying to make sure that everybody get at least 40%. So if you have 4 out of 8, if you have 4 or more than 4 out of 8, we are very glad, because that means that you know your low order questions very, very good. Okay, let's go to question 1.2. Remember, this question 1.1 is out of 8. Short objective questions, and I have covered mid-latitude cyclones. Now we go to 1.2. It's also short objective questions. Why? It says, refer to the map showing pressure cells around southern Africa in January and July. So I see pressure cells. January and July are my keywords, because January means it must be summer. July means it's going to be winter. Choose the correct word or words from those given in brackets. So, yeah, we give you options, and we only give you 2 options, where the previous question we gave you 4 options. Now it's becoming easier. And I have 7, 1 to 1 to 1 to 7. So this one is out of 7. Okay, there's my diagram. Refer to the map showing the pressure cells. We did read through that. The high pressure cell changed position in January and July because of the movement of the ITCZ, or the movement of the Tropic of Cancer. Now, I have, look here, here's my high pressure belt. It's January now, and it's just here to the coast of South Africa. Look where it is now. It has moved a little bit higher. What has caused this northerly movement of the high pressure cell? This, boys and girls, I give you enough time now here for the answer. This is grade 11 basic knowledge. So, I hope, okay, let's look at, before we look at the answer. 1, 2, 2. A coastal or a heat low is located over the land in January. So if I go to January, there you will see the low pressure that they are talking about here. Now you must choose, is it a coastal or a heat low? Boys and girls, this is very, very clear what the answer is. But first, let's look at the first answer. Sorry, there's another one. The high pressure cells move more south or north in July. In July, that's your keywords. Let's look at the answers. ITCZ. ITCZ, the Intertropical Convergence Zone, is responsible for the fact that this high pressure belt are moving north or south depending on the season. We'll talk about that just now. A coastal or a heat low is located over the land. There it is, boys and girls. It's definitely not on the coast. So it can't be a coastal low. It's over the land. So this one you can easily get if you know your grade 11 work. This one is easy because the answer is there. Now I see the high pressure cells have moved. Is it north or south in July? So I'll go to July. I see it was there. Yeah, but it has moved up. So your answer is going to be north. Also, at least 3 out of 7 so far for you. The Indian Ocean high pressure cell carries more moisture to the east coast. Is it in July or January? 1 to 5, berg winds would be a common occurrence in January or July. 6, in January, the South Indian or South Atlantic high pressure cell reach over the southeast coast of South Africa. 7, less subsidence over the interior in July or January causes the inversion layer to develop above the escarpment. Okay, boys and girls. So let's quickly do number 4 again and make your choice as we read it. The Indian Ocean high pressure cell, remember here's the Indian Ocean, cell carries more moisture to the east coast. Is it in July or January? 1 to 5, berg winds would be a common occurrence in January or July. Now you have to know your seasons. In January, the South Indian or South Atlantic high pressure reach over the southeast coast of South Africa. 7, less subsidence, that means sinking, over the interior in July or January causes the inversion layer to develop above the escarpment. There's your key. So let's look at the first one. The high pressure cell, Indian high pressure cell, carries more moisture in the east coast in January. Why? Because then it is closer to the land. Berg winds would be a common occurrence in July. Why? We know berg winds occur in winter. Winter in South Africa is in July. In January, the South Indian or South Atlantic high pressure cell reaches over the southeast coast. Southeast coast. Okay, look at which one is it. Remember, this is the South Atlantic. That one is the South Indian. We are in January, so you have to look at that one. And it is the South Atlantic, and here you can see. Remember, what does it mean when we say it reaches in? If I have a high pressure and it looks like this, one part of it has got that elongated part on the side. This is reaching. That is reaching. If I have a low pressure that's doing that, it makes that longer line. We talk about a trough. So with a low pressure goes toward trough. With a high pressure goes toward high pressure, reaching. Okay, less subsidence over the interior in July or January causes the inversion layer to be above the escarpment. When is this above? If I have the plateau and I go down to the sea, if the inversion layer is above the escarpment, here's the escarpment, air can move over. And then I have rain in the interior, and that can only occur when it is January. Why? in January, we have summer in the southern hemisphere. Wow, boys and girls, yeah, I'm sure it's manageable to get at least 4 out of 7 for this question. Refer to the extract on tropical cyclone Anna. Here's the extract. A moderate tropical storm Anna does not pose any direct threat to South Africa. This weekend saw the first tropical cyclone of the 2021-2022 tropical cyclone season for the Southwest Indian Ocean basin. Towards the end of last week, a tropical low began rapidly intensifying over the open ocean to the northeast of Madagascar, northwards of Mauritius and Reunion Islands. Over the weekend, the system turned gradually from east to west over central and northern Madagascar, temporarily losing intensity due to surface friction with the landmass, as well as the absence of the release of latent heat energy from the ocean surface, the main energy driver for tropical cyclones. Overnight, the system continued to intensify, reaching moderate tropical storm intensity in the early hours of Monday morning, leading to its official naming of Anna. The system tracked westwards and by local sunrise on Monday morning was lying just off the northern Mozambican coastline between Angoshe and Mojinjual. The system then tracked in an easterly direction. This article comes from the Zulu Observator, which is a local newspaper in KwaZulu-Natal. Look at all the geographical information in this article. And to be honest, only if you are a geographer, you will be able to understand what's going on here. So let's go to the questions. How does the name of the tropical cyclone suggest that it was the first of the 2021-2022 tropical cyclone season? My answer for this lies in that word. The name of the cyclone. Eh? So my answer will be, the name starts with letter A. A is the first letter of the alphabet. That's why we would say that it is the first of the season. 1 mark for that. Very easy if you know your work. State one island listed in the article that would be affected by the tropical cyclone. So if we go back to the article, there's the article. Which islands will be affected? Now, I've got Madagascar, I've got Mauritius, and I've got Reunion Islands. Let's go back to the question. State one island listed that would be affected by the tropical cyclone. Madagascar, it's in that article, Reunion, Mauritius. None of you have any excuse of having this one correct. So 4131, that one you must have correct. Let's use this one, that one, and that one. So you already have 2 out of 15 because this is a source-based question. Why are these islands affected by a tropical cyclone? Because they are in the direct path of the tropical cyclone that moves from east to west. It moves in an easterly direction. Sorry, it moves from east to west. 1 mark for that. So I have already 3 easy questions on this topic and on this extract. How does latent heat intensify the tropical cyclone? Intensify means it strengthens it. How does the latent heat makes this tropical cyclone more intense? Now look at the mark allocation, 2 times 2. So you at least have to give 2 facts that can go down 2 marks. Boys and girls, here is a middle order question because here you have to think. You need to know how latent heat, what is the role of latent heat in tropical cyclones. The latent heat is distributed vertical around the center of the storm. Vertical means up and down. For this answer, you will get 2 marks, or this leads to a pressure drop at the surface for another 2 marks, or you can write pressure gradient between the storm and the surface is strengthened, and there you have any one of these 3 options for you. The examiners and the markers will choose any 2 of your answers that can be like this. So I would say this is a bit of a challenging question. So I already have 3 marks out of 15. Let's go on. 135. Account for the tropical cyclone tracking in an easterly direction. Account. We have discussed this many occasions in these lessons. What does it mean to account? You must give reasons. The cyclone moves towards higher sea temperatures for 2 marks, or it encounters a different wind belt. It is in a westerly wind belt. And now that wind belt is driving it in an easterly direction. 2 times 2 is 4. So you have to write 2 facts. Say, for example, you only manage to say it go for higher sea temperatures. Let's estimate you only have 2 marks. Then it means we already have 5 out of 15. 136. Explain the negative economic impact. Negative, we only focus on economic. Impact of strong winds on the infrastructure, the coastal infrastructure of Mozambique. So you only have to go and write any negative economic impact that this can have on the infrastructure on the coast of Mozambique. What is infrastructure again? Roads, railway lines, pipelines, etc. There's my keywords: economic impact and infrastructure. The strong winds, there they are, can cause a storm surge that would damage my harbors. By the way, a harbor, which Mozambique does have, is also part of infrastructure. We will have damage to the harbors, which will limit imports and exports. So I have to stop imports and exports for a while until the harbor is been fixed. This imports and exports will have a direct effect on the economy of the country. Commercial fishing vessels would not be able to go out to the sea. So my fisherman who is catching fish to sell to others cannot go out. So they don't earn an income. It would discourage tourism and its related coastal activities. For example, these pleasure boats cannot enter the harbor, or any coastal activities were fishing from the coast, tourists that are catching fish from the coastline. All of these activities will be influenced. Very easy, 4 marks here. So in total, I think that there will be a loss of jobs in the tourism sector because of this. People are too scared to visit that specific areas, and then to repair the infrastructure is going to be costly. They will have to spend money to repair all this damage that has been done. Yes, this is now out of 15, so I'm going to add another 4. So boys and girls, for this question, it would have been easy to get 9 out of 15. 1-4. Typical line thunderstorm conditions in South Africa. Why is it line thunderstorms? What are line thunderstorms? Just before I go to that, here's the evidence. My low pressure system over the country. Here I can see I have cloudy conditions. There are my symbols. for thunderstorms. Now we ask, what are line thunderstorms? Again, it's basically like a definition for 2 marks. They are storms arranged in a line. You can see there's the line from northwest to southeast over the interior of the country. When? During summer. So it's a line from northwest to southeast over the country in summer. How do line thunderstorms differ from general thunderstorms experienced over South Africa? It covers a greater vertical area. So it's this whole area. Normally, a normal thunderstorm is just a short storm over a smaller area. And they've got a longer duration. And line thunderstorms are more destructive. So out of the 3 options here, you only need to mention one. So if you know your concepts line thunderstorm, this one is easy. You can see it covers a big area, a wider, it's going on longer than a normal one. And line thunderstorms is very destructive. It's easy for now for these 2 questions to already have 3 marks. Refer, there we are, state evidence from the sketch to show that line thunderstorms are prevalent over the central part of South Africa. There's a low pressure over the land. I showed you. There it is. The answer is there in the diagram. There's a band of thunderstorms stretching from northwest to the southeast. There they are. It's those ones. From northwest to southeast. Also on the map. Thunderstorms are experienced on the eastern part of the moisture front. It takes place on this part, the eastern part of the low or the moisture front. Here as well, boys and girls, very easy to get 2 marks. What role did the South Atlantic high pressure cell play in the development of a moisture front in the middle of the sketch? How can the South Atlantic high pressure, so it's this one, what role does it play in the development of a moisture front? So here you have to explain it a little bit. Now it becomes middle order question. It diverges cold, dry, southwesterly winds to meet warm moisture in the central part. Remember, we have anticyclonic circulation of air moves from high to low. So it comes from here. It's over the cold ocean, so it's cold and dry, where I have my South Indian high pressure cell. He comes in from the northeast. This air is warm and moist. So this cold and dry air is going to meet this warm moisture air on this line. Remember, cold air is heavier. So the cold is going to force this warm air to rise, and I have a line thunderstorm. Okay, I would say 2 marks for that. Explain the significance of the northeast winds in the formation of line thunderstorms. This is my northeast winds. What did I tell you? How are those air? It's warm and moist. So it's carrying warm moisture air to the heat low that I have over there. The northeasterly winds are undercut by the cold, dry air and rises along the moisture front. There's my other 2 marks. So for this one, already 4 marks is very easy. So if I'm correct, we are at 9 marks. Why would line thunderstorms have a negative environmental impact on the eastern half of the country? Here's my keyword, negative environmental impact. So how is it going to negatively impact the environment? Valuable nutrients in the soil are washed away because it's rain, very intensive rain. The soil nutrients will leach down, lower down the soil profile, which will make the soil less fertile. ecosystems or food chains are destroyed, there's a decrease in the biodiversity, aesthetically is diminished beauty, and vegetation are flooded. So we are losing food. Wildlife can be drowned. Okay, boys and girls, for this one as well, it's easy then to get at least 12 out of 15 for a question like this one. I'm going over to 1.5 is the last question for climate. Refer to the sketches showing the difference between rural and urban climate. So yeah, I've got my rural areas. Yeah, I've got my urban areas. You can see the sun and the insulation. What is insulation again? Incoming solar radiation. Okay. The climate element illustrated in the sketch, is it wind or temperature? How does the climate element affect the amount of humidity in rural areas? So first of all, you have to make a choice between these two. And then you must say, how does this climate element affect the humidity in rural regions? So always it's temperature. Why? We look at the difference in temperature between rural and urban. Now, how will this affect the humidity in rural regions? It will increase humidity as there's more dust, there's more water sources in the rural areas which assist with evaporation. Explain how the different shapes and density of buildings contribute to the city having a higher temperature. Remember, these buildings are very close to each other. Ne? Okay, the tall buildings cause the sun rays to be reflected and deflected between the buildings. If you look at the diagram, I'm quickly going back to the diagram. Look here, reflecting and deflecting. So there you have the answers in the diagram though. Large surface areas of buildings absorb more of the sun's rays. Or the density of the buildings ensure that the heat remains closer to the Earth's surface. Remember, if you are a group and you stand close to each other, you are warmer. So for this one, any two, and I think it's easy to get 2 marks for this one. Then in here it is again, in a paragraph of approximately 8 lines, explain how urban planners could put strategies in place regarding the shapes and the density of buildings to reduce the higher temperatures. So you have to come and explain how an urban planner, what strategies they can put in place when they design the shape and the density of buildings to make sure that it reduces the high temperatures. Remember, we are putting in point form. You have to write the paragraph. We can paint the buildings in lighter colors, for example, white. You can plant gardens in the rooftops. Buildings should be eco-friendly. Future land use planning should coincide with prevailing wind directions to cool the cities. We can decentralize commercial activities to reduce building density. We can decrease building height to reduce the heat trapped by the buildings. And we can decrease building density to reduce the heat near the surface. We can have filters in chimneys of buildings to reduce air pollution. Now, it's a paragraph question, 4 times 2. Now, boys and girls, this is now the end of climate and weather. So, for this question, it's also easy to get at least 11 out of 15. I'm going to give you a 1 minute to quickly plot down these answers. And then I'm going to give over to Miss Cynthia Zondi to do the geomorphology part with you.
afternoon, boys and girls. I am Cynthia Zondi, and I am going to continue with our next topic, which is part of your paper 1. My colleague, Rina, has done a good sterling work in trying to help you and understand the concepts that you need to show understanding of in the topic of climate and weather. With the question that she left you with to do, I hope you did manage to plot down your own answers, and you can be able to compare and see how best you can respond to that question. Right, I am going to look at the section on geomorphology, which is question 2 of your paper 1. This forms question 2 of your paper 1. Right, okay, I've got a question up already for you, which says, refer to the sketch which shows the river profiles. Complete the statement in column A with the options in column B. Write only Y or Z next to the question number. So when you look at this instruction, just before you can even think of starting to do your answers, you must take note of what instruction you are given. You are supposed to only give your answer in the form of letter Y or Z, and in the order of the numbering that you will have on your question paper. Okay, and then what we can also see here, it is a beautiful diagram that is showing us the aerial view of the river profile. This one is your aerial view, and then we also have your cross sections of the whole river profile there. Okay, before we can go deeper into understanding the details of each of these diagrams, let's look at what questions you have here. Right, on column A, you've got the cross profile. You have the cross profile, and then you have to either choose the answer on the statements that are given on column B. It says Y is a side view of the river, or Z, a view from bank to bank. So if you are to explain what a cross profile is, so we're saying we're looking at the cross profile here, and then from the options that you are given, are we looking at the river from the side? Like, is it as we are looking at it from this direction down there, or we are looking at it from bank to bank? So these diagrams here are showing you the bank to bank. So a cross profile is a view of a river from bank to bank. So when we are looking at the side view of a river, we would just be looking at the longitudinal profile of a river as it is from the source to the mouth. So this would be the mouth, and then these mountain ranges that you see here are the source of the river. Okay, let's look at the next question. It says the dominant fluvial process in the middle course. So we have a river that we are looking at it in both profiles, and then we are now asked to identify the dominant fluvial process where in the middle course. So you have been given these cross profiles here that are indicating the upper course. This would be your upper course, and this would be your middle course, and then this would be your lower course. So in which of these river course are we going to find, which of the, the dominant fluvial process in the middle course, which one is it? Is it lateral erosion, or is it vertical erosion? So which processes are dominating in the middle of the river? So if we are looking at it from the cross profile, we would be focusing here. And then you have to be able to analyze the diagram by looking at the shape or the change in the width of the river there. So if we look at this first diagram here, we can see that the valley is very deep and narrow. And then when you look at it now from this part of the diagram, now the valley is becoming wider. So you can see that the valley is now widening. And then furthermore, as you look at the lower course. So now, which process would be dominant in the middle course here? Before you can come up with your answer, you must be able to know these different types of erosion, how they differ from the other. So we've got lateral. Lateral means side. So this one, it means erosion is taking place on sideways. And then if it's vertical, it means erosion is digging vertically deeper. And then the third question, it says the fluvial landform that encourages farming. So, okay, for these ones, I will show you the answers here as and when we move to the next slide. I'm just explaining each and every question as to how you should be able to get the correct answer there. Okay. Then we've got the third question, which says the fluvial landform that encourages farming. So here now we are looking at what? The landform that encourages farming. Okay, so we've got a floodplain. So you have to know what is a floodplain, and then you have to know what is a waterfall. So looking at these two landforms, which of the two landforms do you think it would be most appropriate for farming to take place? So floodplain, just looking at the word plain, it gives you a guide to the fact that it would be an area that is more like more or less flat, because it says plain there. And then a waterfall, we've all been seen how waterfalls are like, but do you think farming can take place in such an area? I don't think so. Therefore, it means the correct answer here, it would be, the correct answer, this one, it would be wrong. And then the correct answer would be a floodplain. So that one, it would be a fluvial landform that can encourage farming because it is flat. Then 214, fluvial deposition encourages the formation of. So here now, what is your key word here? It's deposition. So where deposition takes place, which of the two landforms can be formed? So we've got the option of, is it a delta or is it a rapid? Right. You have been taught on how deltas are formed as well as how rapids are formed. So these landforms, as we have them here, deltas would form at the lower course of the river. And then even when you go to your diagram here, it says fluvial deposition. So can you see there is some guideline that it will help you to have an understanding of how to get an answer. So deltas cannot be formed in any of these river course surfaces. So, but deltas, we find them where? Towards the mouth of the river there. So then the process that takes place for us to have the formation of deltas, it would be deposition. So deposition would be the correct answer there. And then you cannot choose this one. This one is not correct. The rapids, because rapids are found at the upper course of the river, and it is the landform that is formed over the uneven surfaces that is formed as the river erodes into different gradients. So then we cannot take this one. So rapids are formed due to erosion. So your question here is talking about deposition. So you cannot choose that one. 215, the volume of water in the upper course of the river. So even when you look at the diagram that you have here, you must be able to deduce the amount of water. Even from this diagram, you can see here, the streams, they've got less water. As you can see, they're showing a very fine line that is indicated here. But when you go to the cross profile as well, when you look at within this deep, narrow, the V-shaped narrow valley here, the amount of water that is found at the upper course would be less water. And then if you look at the middle course, we see now the stream, it's getting wider. And then it means there is more water that is now contained within the river channel. So for this question, it says the volume of water in the upper course. So the correct answer, it would be this one. It would be low. And then the source of a river can be found in that one I've also tried to elaborate and then show you. We are looking at the source of the river, which is it the upper course or is it the lower course? Source, it's where the river starts. So the river starts at the upper course. So the correct answer would be your upper course. And then 217, the area drained by a river and its tributaries are known as, is it a river system or is it a drainage basin? So here, what are you checking before you come up with your answer? We're looking at the area that is drained by a river and its tributaries. So that gives us a correct answer to be the drainage basin. Okay, and then 218, V-shaped valleys in the upper course is caused by, so here we're looking at the V-shaped. So when you look at the valley here, it's very, it has that sharp V. So in the upper course, it is caused by what? For a river to have this V shape, it means there is vertical erosion. Erosion is cutting deeper into the valley. It's cutting deeper into the valley. So it's unlike when we have to look at what lateral erosion is. Lateral erosion, it means the river, it's eroding and it's getting wider. So it is on sideways. So lateral means sideways, and then vertical, it's downward. So the shape of a valley that would be that would have a narrow V would be due to the process of vertical erosion. Okay, these are the answers. As I have indicated, 2.1.1, the correct answer for that one, we said it's Z. You can see it's correct. And then 2.1.2, the dominant fluvial process in the middle course is lateral erosion. So in the middle course, we have lateral erosion. I've just also explained here. And then fluvial landform that encourages farming. So we need a surface that is flat. A flat plain would be the correct one. And then fluvial deposition encourages the formation of the correct answer for this one, it's Y. So we're saying due to deposition there, we've got the formation of deltas. Rapids cannot be formed due to deposition. Rather, they are formed due to erosion. Okay, the volume of water in the upper course, the correct answer for that one, it is low. I have indicated to you that even when you look at the streams here, they're indicating that there is less water that we can find there. So it's low. The source of a river can be found in the upper course. That one is straightforward. The area drained by a river and its tributary and are known as, the correct answer there is a drainage basin. And then the last one also, we're saying the V-shaped valley in the upper course is caused due to vertical erosion. So boys and girls, in this type of question, you can see some of the statements here can help you to correct the wrong answers that you would have picked as and when you were starting to answer this question. Right. Then let's look at the next question. It says, refer to the sketch of river rejuvenation. So now we are looking at the river rejuvenation. Choose the correct word or words from those given in brackets. Write only the correct word next to the question number in the answer book. Please take note of the instructions. The instructions are there. If you are asked to give only the word, do so, as the rewriting a questions would waste your time and you will not be able to finish your exam. Right, so in this diagram, what we have here, we've got the situation where it is before rejuvenation and after rejuvenation. So before you can even answer your question, you must look at the diagram itself and look at what are the developments or the changes between these two floodplains, okay? And then we've got the identification of landforms such as the floodplain there, and then we've got the tributary, as you can see there, and then also, so this would be before rejuvenation. So the river, it looks like this, and these are the only features that you can see. And then also what you need to take note is the size and the width of the valley there. You look at the size and the width of the valley, and then also notice the changes that takes place after rejuvenation has taken place. So we still have our original grade section of the river. So the river is still in its original form, okay? But then now we see the development of other features that were not there before rejuvenation. So we can see now there is a development of a nick point that is formed in this section. And then it may not be clear to see that unevenness, because the diagram that you are looking at, it's from the, it's a top view. It's a two-dimensional view of this. But if you were to also to be able to answer some of the questions, you must answer them looking as if you are standing in front of the river. Then you would see the change of the features that I will later emphasize here, okay? And then we've got the rejuvenated river flowing in a valley, So now, here we only had one specific wide valley. But then now, when we look at after the rejuvenation, we see now the development of valleys within valleys. So we see a development of valleys. So initially the valley was at this position, and then because of vertical erosion, we see another development of another valley here, and then the river would be flowing in between this development of valleys within another valley. So here we see now that undulating feature that is showing us the development of valleys within a valley. And then other landforms that we can also identify here, it's a rapid. A rapid would develop because of the nick point. So if maybe, for an example, from the diagram that I have drawn here, I would say I will label this part as the nick point. So if this would be labeled as a nick point, it's not very clear. So I'm saying this is my nick point. Then if the water is flowing, or if you were to look at it, but on the, rather, if you were to look at it, but on the top view, you would have this forming an uneven surface along the river channel. So the water that would then be flowing within the river channel would be having some uneven surface that it is flowing on. and then this would result in a development of those rapids. It's just formed over a sudden drop of the surface there. It wouldn't look as high as a waterfall. If it's a waterfall, it would look much more elevated. And then we see other developments of other, okay, this one would be a river terrace. So from the development of valleys within a valley, from the diagram that I have drawn here, so these steps-like features, we call them river terraces. So terraces are your step-like features that you see now formed here. It's no more as straight as it was here, but now we see this up and down formation of valleys within another valley here. Okay, so then with the understanding of the diagram that I have shown you, let's look at how then you can be able to come up with the correct answers for these questions. It says refer to sketch of rejuvenation, choose the correct word. Okay, I've given you the instruction. Let's look at the first question. River rejuvenation is the process where a river erodes laterally or vertically. Again, and then the second question, the point where the old erosion meets with the new is called valley or a neck point. And then the third question, it says river rejuvenation is caused by a drop in the sea level or watershed changing its position. River terraces from before or after rejuvenation. Number 5, valleys in a valley or rapids, they form on a floodplain. And then number 6, tributaries after, the tributaries after rejuvenation lengthen due to, is it because of headward or lateral erosion? Right, the last question, river rejuvenation will cause the river profile to be graded or ungraded. Fine, let's look at how then you would be able to score marks in this type of question. River rejuvenation is the process where a river erodes laterally or vertically. I have taken time to explain how the river, the erosion process will take place there. So for a river to be rejuvenated, the vertical, the erosion process there, it has to be vertical. So the river cuts deep into the valley. Okay, and then the point where the old erosion meets with the new is called a valley or a neck point. So here now the question is the point where the old erosion meets with the new. So if the landform was initially just a open V like that, if it was just like that, and then we now find that there is further erosion which will cut deeper into this. So we've got now development of river valley within another river valley. So here now we see a development of what? Is it a neck point or are we going to see a development of a valley? We already have a valley from the first diagram, but then now we see the development of these uneven surfaces that we find within the river valley. And those ones, we term them the neck points. River rejuvenation is caused by a drop in the sea level or watershed changing its position. When the sea level drops, it allows the water to flow in faster. So this results in the process of river rejuvenation taking place. So if the sea level drops, so the dropping of the sea level would make water to flow in faster. And as the water flows faster, then it becomes more erosive. So this will then result in the development of river rejuvenation. River terraces, do they form before or after rejuvenation? They form after. From this structure that you can see, here the river has not rejuvenated. Here there's no, this one, it's just a river valley without rejuvenation. But when we look at this diagram that I have indicated here, this is where now we see that the river has regained its energy and it started to erode faster, which then results in the development of those terraces. Terraces are your steps like of the steps-like features that we find as the river cuts deeper. Then valleys in a valley or the rapids form on a floodplain. So we see a development of what? Of valleys in a valley within what? A floodplain. Initially, the floodplain would be on these sections of the valley. So here it would be where we have the flat part of this river. And then when erosion takes place, then we see now the impact that we see on the floodplain. So the floodplain, it's the sides here, and then when we have the river flowing there, so these are the floodplains. But due to the river rejuvenation, then we see the changes over there, the floodplain there. And then the tributaries after rejuvenation lengthen due to lateral or headward erosion. If we go back to the diagram that I initially indicated to you, you can see that initially the tributary was at this point. But then now, after rejuvenation, can you see now the source of this tributary? It has moved headward. So the process of erosion that takes place here, we say it's headward. So the tributaries also, they now expanding headward to where its source is. Okay. Okay, let's go back to the questions that we are working on. I just wanted to show you the changes that we observed on that diagram. Right, the tributaries after rejuvenation, they lengthen towards the source, and then we say the correct answer there is headward erosion there. And then number 7, the river rejuvenation will cause the river profile to be graded or ungraded. If we talk about a graded river would have a smooth concave shape from the source to the mouth. But if we talk about an ungraded river, remember we have mentioned formation of landforms such as neck points, terraces, valley within a valley. So now the river profile here would not have a smooth concave, but rather we would see a development of uneven profile there. So this kind of a river profile, when you look at it from the source to the mouth, it is not having a smooth shape. So river rejuvenation will cause river profile to be ungraded. So the correct answer for this last one is it's ungraded. So when you are asked to draw a graded and ungraded, you just draw a smooth concave line indicating your source, and then you indicate your mouth there. If it's ungraded, it will have this unevenness, and then the features that you will label here, it would be your neck points. All right, let's see further the other questions that you need to be readily prepared for. Here now we're looking at the image or a sketch of flow of water in a river. Okay, the first question, it says, classify the water flow as laminar or turbulent. So boys and girls, when you look at this diagram, this would be the illustration of the two flow. So here, it would be linked to this, and then this part of the diagram would be linked to that. So we've got two types of flows here, which is laminar and turbulent. So just by looking at the diagram itself, this is the reality, okay? So look at how the surface or how the arrows are portraying the flow of water here. If you look at the flow of water here, is it smooth or is it bubbly, kind of rotational kind of flow of water? And then when you look at this one, we're looking at water that is flowing smoothly in sheets. So you can see even the arrows are trying to guide you here that water is flowing smoothly in sheets. So classify the water flow as a laminar or a turbulent. So this one, we say it's a turbulent flow, and this one we say it is a laminar flow. So sketch A is a representation of a laminar flow because we can see that the water is flowing smoothly in sheets there. Right, the next question. How did the riverbed determine the type of water flow in sketch A? To your answer that you gave in question 2.3.1. How did the riverbed, so we're looking at how did the riverbed determine the type of flow? So you must explain how. How did the surface over which this water is flowing determine the type of flow that we see there, okay? In your answer, you should mention that the riverbed is smooth. I have mentioned that the riverbed is smooth, which allows, so can you see the how part now where we are explaining how the riverbed has an influence on the flow, which allows the water to have a smooth flow, okay? So it is smooth, therefore it allows water to have a smooth flow, right? Or you can say there are no rocks or obstacles to cause the friction. So if the water is flowing smoothly like this, there's nothing that is saying there's undulating or uneven surfaces here. So there are no rocks or there are no obstacles that cause the friction. So if there is friction, then water would be rolling, as we can see here in this illustration on B. Okay, refer to the image and sketches of the flow of water in a river. Why would the water flow in sketch A encourage deposition? So now we want to know, why would there be deposition taking place? Where? In sketch A. The water has a low velocity. So here water is flowing at a lower speed. So if water is carrying any sediments or rocks, then there would be deposition of such material because the water is flowing at a low velocity then. And then also, the river cannot transport all its load, which results in deposition. So the load becomes heavy for the river to carry here. And therefore, this river will start to deposit whatever that it is carrying. So that's how deposition will be formed by a laminar flow. Right, the next question. In a paragraph of approximately 8 lines, explain how. Remember, boys and girls, you must always have your highlighter in the exam room so that when you get to questions like this, you highlight the question part. Explain how the fluvial features and the steep gradient. So here now, you've got two parts of what is it that you should look at. We're looking at the fluvial features, and then we're also looking at the steeper gradient or the slopes, where on the upper course, how they impact on the flow of water in sketch B. So your focus now is here. So we're looking at how the fluvial features and the gradient, a steep gradient in the upper course, can impact on the flow of water here. Right, so the first answers that we're going to give would be answering the how the fluvial features would impact on the upper course. Okay, the narrow V-shaped valley causes friction, which slows the flow of water. So we're saying here the valley is narrow, and therefore there is friction. So if there is friction, water would flow slowly then. Okay, the traction load causes swelling movement. So the load from the sediments that the river is carrying would cause some swelling, and therefore that would impact on the movement of water. So the water will swell due to the rocks that it's carrying. The load that we are referring to are those smaller particles that are broken down as weathering takes place there. Okay, and then waterfalls increase the velocity of water and swelling movement at the plunge pool. So the waterfalls, so we're looking at the feature here, which is the waterfall. What does it do? It increases the velocity of water. So when water passes over the waterfall, obviously it would move in a speedy, high speed there, and that has an impact on the swelling movement of water in the plunge pool. So we see this right at the bottom of the diagram here, where we see that surface of the plunge pool. So water swells there. Rapids increases the velocity of water over the outcrop or the layer dipping stream up. So here now, which landform we're looking at? The rapids. What does it do? It also increases the velocity of water. And then that impacts over the outcrop rock that the river is flowing over there. Right, then we look at how the steeper gradient has the impact on the flow of water. With the steeper gradient, it increases the velocity of water. If the slope is more steeper, obviously the water will flow faster. Uneven slopes cause swelling movement. So these uneven slopes there, they cause the water to swell up as it flows in the river channel. Then for you to have or to be able to score your 8 marks, you must take note of this. Both the fluvial features and the steep gradient must be mentioned. So you cannot answer only on the landforms. Can you see we've got so many answers that we have put under fluvial features because we looked at all the landforms there. But it doesn't warrant you to get the 8 marks because you have not answered the complete question. So you must also give some facts about the steeper gradient. It may not necessarily mean it must be a balance of 2-2, but you must answer both of the questions there. Refer to the sketch for the formation of a levee. Right, here we've got a levee, and then we are now looking at the formation of how a levee is formed. What is a natural levee? A natural levee is an embankment formed after river floods, or when the river, it is naturally raised, the river banks there. So we've got the embankments that are formed due to flooding. So if we look at before here, we don't see anything on this part of the river banks, right? So when we now define a natural levee, it's when now we see the changes that is formed, where now there is something that we can identify here. So the deposition of this soil sediments alongside the river banks there, they form what we call a levee. And this one is a natural levee. The next question, 2.4.2, does sketch A, B, or C reflect the flood stage? So when you look at this, all these diagrams, is it A or B or C? Which of these sketches reflect the flood stages? B is the correct answer, boys and girls. You can see here there's water that has come out of the river channel and is now overflowing outside here. So that's where we can see the flooding taking place. 2.4.3, how does flooding of a river contribute to the formation of the natural levee? As you can see, when a river floods, it is carrying some sediments. So these sediments, they get deposited here. So they get deposited here. And then it says here, thickest and coarse sediments deposited on the channel. So take note of this information. And then we also have thin and fine sediments deposited over outer parts of the floodplain. So what you also need to note is that why is it thicker on the side and then why is it thinner on the other side? It depends on the strength of the river at this bend. So if it's thicker, then it means this river is able to carry the large boulders because of the speed at which it is flowing. But if you look at the thin ones that we can identify that are deposited here, so it means on this bend of the river is flowing not in a high speed, it's the inner bend. So the sediments that would be deposited there would be the finer ones. So how does flooding of the river contributes to the formation of the levee? After the water floods, recedes, it leaves behind the gravel, the sand, and silt, which builds up to form the raised bank. So we can see here the water has receded. At first, the water was overflowing here. So now the water has receded, meaning it has lowered down. So then this leaves the deposition of this sand and silt alongside the river banks. And then flooding causes deposition of the coarse material at the edges. So we see the deposition of these sediments on the edges of the river banks. And then continuous flooding causes buildup of sediments on the banks. So we saw the development of a levee from this stage to this stage. So we can see now there's the heap of silt and sediments that is now deposited here. It's higher up. Let's look at what other questions that were asked that you can have a better understanding of. What is the significance or the importance of the thickest and coarse sediments being deposited to the formation of the natural levee? So these sediments, they are not easily transported away. So we're looking at how important are they. So they are not easily transported or washed away. And then these sediments, therefore, bring stability. So they bring stability to the raised bank. So that's where we see now the most significant importance of these sediments of over the river banks. How is the formation of a levee of a benefit to a floodplain? So the floodplain, we said, is the sides of the flat surfaces alongside the river. So how are the formation of levees benefiting the floodplain? It reduces erosion of the floodplain. Why? Because if this river floods, it will not just be easy for it to flow out of the river channel. So it has increased the elevation of the river banks, and therefore it is effective in flood control as it acts as a buffer. So it acts as a buffer that can protect the surrounding flood plains. It decreases flooding so that the floodplain does not become waterlogged. And then it also preserves the habitats and the ecosystem that we find alongside the river there. Last question, explain the negative impact of levees to the surrounding farming community. So how are people impacted there? Mostly the farmers there. It makes it difficult for farmers to access the water. Remember now the water would be down and deep into the stream, and then it becomes costly for farmers to source the water because it's not easy for them to access the water as the river now it's deeper. And then the river becomes inaccessible for livestock. These raised banks, they make it difficult for livestock to have access to water. The alluvium or the silt that is not deposited regularly on the floodplain, causing soil fertility problems. So the soil can grow to be infertile. Right. So the other option of the answer that you can give here of the impact of the levees is that production will decrease. So the farmers will be impacted negatively, and therefore there will be no enough productivity in the farms. Farmland will be flooded if levee breaks. So in case this levee breaks, then the water starts flowing out. Then that would also cause a disaster. Okay, any two of those answers. Right. We are running out of time, but we are going to look at this question, which is based on the extract. According to the extract, Why are cougar bavians and chrome catchment areas important? So boys and girls, here now, I'm not going to take you to the extract, but I just want to show you that there are some of the answers that you can get straight from the source itself. This answer is from the source. And then the next question, what is a catchment area? This is a concept. You have to know and learn it by heart. It is the upper reaches of a drainage basin that supplies a river with most of its water. The area that captures the rainwater. So when rain falls, that area that captures the rainwater, we call it a catchment area. Then the next question also says, quote 2 physical factors. So if you come across questions like this, boys and girls, you should know that your answer is in the extract. Quote 2 physical factors from the extract that impacts negatively on Port Elizabeth catchment areas. These answers, if you go to the source, you will find the answers it's given right into to your understanding to put down there. Climate change, droughts, and erosion. What is the negative impact of poor planning on the catchment area? The river, it becomes polluted. So these are the impacts of if we don't manage our catchment areas well. Dumping of industrial waste, inhabitants that contaminate the water, pollution that we cause onto the river, eutrophication from animals will also increase, water quality will decrease, and river will silt up. That is not good for the river, as it will impact on what? It will impact on the ecosystem and it will be destroyed. Settlement development will destroy natural catchment areas. We see so much of development of the settlements, and this impacts on these natural catchment areas. Any of this, it's because of the poor planning over the catchment areas. Okay. And then the last question there, why would the interbasin water transfer scheme not be viable or a solution to increase water supply to the cougar? It is too expensive to construct. It would affect the flow patterns of a river, and it will also disrupt the aquatic life there. Explain how the sustainable management of the cougar, bavians, and chrome catchment would have a positive impact. So we're looking at the positive economic impact. So here now you must be very careful. You only have to focus on the economic impact in the city of Port Elizabeth. So your key areas are job opportunities. It would supply the areas with there would be a supply of water quality over to the farmers. And then the industries will also benefit as there is consistent and productivity that is maintained. It will attract further industrial investment. When you look at all these answers, boys and girls, all your answers are centered where? On the economic impact, multiplier effect, which is a resultant of more jobs that will be created. This video is meant to be a motivation to you, but unfortunately, because of time, I will not be able to play it for you. And that brings us to the end of today's lesson. Let's meet next week when we're discussing paper 2, and have a great evening. Thanks.